Hey guys, what's up? My name is Ali Mutsa Jalbani, and I'm going to be solving this particular paper with you guys. And it is Summer 16 question paper 1. That is, we are going to be solving some MCQs. And this variant is variant 2. Anyways, we are going to be solving this paper. Let's just begin solving it without wasting much time. And let's see which quantity with its unit is correct. Now this is which quantity with its unit is correct. Let's see. Acceleration of the bike is 1.5 meter per second. You can clearly see that we happen to have a problem. The problem is that the unit of acceleration is actually meter per second squared. And this unit is incorrect. So obviously this is not going to be true, right? Electric current in a lamp is 0.25 ampere per second. That is also wrong because current is supposed to be in amperes, so this is wrong. Electric potential difference across a battery is 8 joules per coulomb. So potential difference PD, or we can call it voltage in PD, is actually work done over charge. अगर ये work done over charge है, तो the unit should be joules per coulomb, right? So this seems to be correct. Actually, not even seems to be. This is correct. C answer हुआ इसका. Simple as that. Let's just move on to the next question. The luminosity of the star is given by this expression, which is 4 pi r square sigma t raised to power 4. Basically, this luminosity thing is going to be tested in A2. लेकिन अभी तो हमारे पास ये ऐसे ही आया होगा. वैसे luminosity का मतलब होता है total power. इसका मतलब होता है total power. तो इसका unit तो वैसे भी watts होना चाहिए. The unit should be watts. That is if you are going to be taking a retake. Yeah, accelerated there. Okay, this question is going to be a piece of cake. But let's just assume we don't know about A2. We don't know whatever is this total power or this luminosity thing is. So let's just assume we don't know anything. So let's just do this question with only the knowledge required by advanced subsidiary level, which is AS. The luminosity L of the star is given by whatever the expression we have. I'm not going to read that expression. R is the radius. Okay. T is the temperature of the star, and we happen to have a drapule sign over here, and sigma is a constant with its units watt per meter square, and k raised to power minus the quad, whatever that is. What are the SI base units of L? So let's just see. Let's just derive these units and let's see where we stand. So L should be equal to a constant. We are just going to ignore the constant over here, which is 4 pi, and R, because these constants do not have any units, so we're just going to ignore it. But we are not going to ignore the sigma, which is also a constant, by the way. Anyways, because it has its units, radius should be meter square. Sigma is watt per meter square multiplied by k raised to power minus 4 multiplied by the temperature raised to power 4. So that is going to be Kelvin raised to power 4. So we can see that these cancels out. ये तो cancel हो गया बहुत simple से. So we are left with L के जो units हैं that are going to be watts. So what is the unit of watt? तो इसका जो unit होगा, that should be let's just see what is the unit of power. So power is actually work done per unit time. So work done is force into distance over time. The unit of force in SI base unit is kilogram ms minus 2, and the distance is actually meters. So this is divided by S. And if you just simplify this thing, m square s minus 3. So C is going to be the right answer. Let's just move on to question number 2, and question number 3. Let's just look at this diagram. The diagram shows two vectors x and y drawn to scale. Okay, they are drawn to scale. Okay, but obviously there is no concept of scale when I'm just solving it digitally, right? Because I can zoom in, I can, tamper with the scales. So we are just going to, let's see whatever this question is all about. Anyways, if x is equal to y minus z, which diagram best represents the vector z? Okay, so x should be the resultant vector. If this is the resultant vector, so we are just going to draw this diagram. Let's see, this is x, right? So I'm just going to copy this x. Well, in the examination, you are not going to be supposed to be doing whatever I'm going to be doing here, but let's just assume that I'm in the examination myself. Otherwise, मैं क्या करता, मैं the line banata, I would have drawn another line and I would move the lines around. But obviously, you are not going to be doing that in the examination because there you are going to be solving this question on a piece of paper with limited resources. Hopefully, you are going to be carrying a calculator, unless, of course. Anyways, this is going to be x. This is vector x. This is the resultant. So I'm just going to put two arrows over here to signify that this is the resultant. Y is positive, so this is the correct direction of y. So I'm just going to connect this thing. Okay, I'm just doing trial and error and seeing if this actually fits in. And I'm just going to draw this line using a green color. This is actually z. This is z, but the problem is that we happen to have a minus sign. So that means z is actually pointing this way. And this is z. I'm just going to write this down. This is z, and this was supposed to be y. Let me just look at this diagram, and does it make sense? It definitely does. Let's see. If I'm just going to be focusing on the resultant vector, this is going to be the start, and this is the end. So we are supposed to move like this. यूं जाएंगे, we're moving like this, and then obviously this matches the direction, so the sign is positive. But then problem is that we have to go all the way this way, and we can clearly see that the sign doesn't match this movement. So it has to be negative. It has to be negative. So that means z should be pointing. The direction that I have selected is actually correct. So let's see which is the closest thing over here. It has to be a. This is done. Let's just move on to the next question. Oh my god, I think this is the most difficult question in the entire paper because मैं सोचना बहुत पड़ा है and most likely people do not have this thinking ability. So let's just try it out. Actually, it is even very difficult to explain this question. The diagram shows the speed cathode ray oscilloscope being used to measure the rate of rotation of a flywheel. Okay, so we happen to have a flywheel, and M is supposed to be a magnet. It is supposed to be a magnet, so I'm just going to mark this as the magnet. The flywheel has a small magnet, which is mentioned here. Each time the magnet passes a coil, a voltage pulse is generated. Well, if I'm going to give you some insight into this idea, is that this magnet is moving, it is crossing the coil, so that means the magnetic field lines of this magnet will actually cut the coil. So, from your O-level course, you know this is going to induce a voltage inside the coil, and that would generate a pulse due to Faraday's law. Anyways, the flywheel has a small magnet M mounted on it. Each time the magnet passes a coil, a voltage pulse is generated, which is passed to the CRO. The display of the CRO is 10 centimeters wide. So that means इधर से लेकर इधर तक का हमारे पास है 10 centimeter, 10 centimeter. The flywheel is rotating at 3000 revs per minute, revolutions per minute. Okay, let's do some calculations. Before even reading the question, I'm just going to do some calculation. That is being impulsive, but sometimes impulsive behavior seems to work. So let's just see. 3000 revs happen in exactly 1 minute, so 60 seconds. Let's just find it out. 1 second में कितने हो जाएंगे? This is going to be 50 revs, right? So 50 revs happens in 1 second. So 50 revolutions in 1 second. So that means this is the frequency. If the frequency is 50 hertz, we can easily find the time period. I don't know, I haven't read the question yet. So this is going to be 1 over 50. And that should be calculator. We happen to have the calculator with me in my hand, and that is 1 over 50. And that gives me 0.02 seconds. Okay, that's good. सही है, यहां तक तो हो गया. ये तो टाइम पीरियड मैंने निकाले. अब let's just read this question and let's see what this question is all about. Which time based setting will display clearly the separate pulses on the screen? Okay. So the question is saying कि हमारे पास pulses clearly separate नजर आनी चाहिए. अगर ये pulse है तो इस तरह से हमें pulse नजर आएगी. तो at least we would be able to read these pulses, right? So let's just see what is happening in over here. 1 second अगर हमारे पास टाइम बेस्ड सेटिंग है, मैं उसको रख रहा हूं 1 second per centimeter. So that means 1 सेंटीमीटर जो होगा वो somewhere over here होगा. This is going to be 1 centimeter, right? So we happen to have 1 second over here. So this is going to cover 1 second. Let's just see what happens. So in one time period, there is one pulse. That is something that we found out from here. ठीक है, यानी ये जो मेरे पास टाइम पीरियड आ रहा है, इसका मतलब है कि हमारे पास एक पल्स जो है वो 0.02 सेकंड्स के अंदर हमारे पास एक पल्स आ रही है. वी आर गेटिंग अ पल्स in 0.02 seconds. So let's just see. I'm just going to write it down. One pulse is to 0.02 seconds, which is also per centimeter. तो 1 सेंटीमीटर में हमारे पास कितनी आ रही है? Let's just check this out. So 1 second would mean that we get just cross multiplying this thing. So this has to be 1 divided by 0.02. We're getting 50 pulses. My God, that is going to be a mess. यानी हमारे पास 50 pulses इसके अंदर आ रही होंगी. Oh my God, this is going to be a mess. So this is obviously not acceptable. We need clear separation. We need clear separation over here. So let's just look at the second one, 10 milliseconds. So I already have the working over here. So I'm just going to just copy paste this thing over here. So we happen to have one pulse is to 0.02 seconds. And this time we have 10 milliseconds. So this is going to be 10 milliseconds. So 10 into 10 raised to power minus 3 seconds. And let's just see 10 milliseconds में क्या होता है हमारे पास. Let's just, we are trying option B. This was option A. So this is going to be 10 into 10 raised to power minus 3 divided by 0.02. And this gives me half pulse. Half pulse in in 10 milliseconds. So that means half pulse in 1 centimeter. तो इसका मतलब है कि हमारे पास 2 सेंटीमीटर्स के अंदर एक पल्स हमारे पास लाजमी आ जाएगी इसके अंदर. So that is actually quite good. That means in 10 centimeter we'll be getting 5 pulses, right? So we are going to get 5 pulses, which means the visibility is going to be really good. I can just mark this. This might be correct. Let's see if we have a better option. Let's just move on to option C. So one pulse again is equal to 0.02 seconds. And we want, हमारे पास क्या है? 0.02. So we have, कितना टाइम है हमारे पास? जो टाइम है that is 100 microseconds. So 100 into 10 raised to power minus 6 seconds. Let's just find the number of pulses we are going to be seeing. This is going to be 100. बहुत छोटी आएगी, but let's just see. 100 into 10 raised to power minus 6. And this is then divided by 0.02 seconds. So we are seeing 5 into 10 raised to power minus 3 pulse. Oh my God. अच्छा चलो यहां तक तो आ गया. मतलब इतनी हमें सिर्फ पल्स नजर आएगी, इतना मतलब 1 सेंटीमीटर के अंदर. सो लेट्स जस्ट सी, इतनी अगर हमारे पास पल्स नजर आए, if you are seeing this much of a pulse in 1 centimeter, so how much pulse are we going to see in 10 centimeters? Are we even seeing a full pulse in 10 centimeters? Let's just see. It should be a whole number. अगर नहीं आएगा whole number तो इसका मतलब है कि nope, we are seeing only 0.05 pulse in 10 centimeter. So that means this is a flop. This will not work. और अगर हमने अभी देखा कि ये वाला काम कर रहा था, तो वी वर गेटिंग 5 पल्सेस इन 10 सेंटीमीटर, लेकिन इसके अंदर तो हमारे पास 0.05 पल्स आ रही है इन 10 सेंटीमीटर्स, तो इसके अंदर तो फिर हमारे पास और भी बड़ी वैल्यू आएगी, और भी छोटी वैल्यू आएगी. सो दिस इज ऑब्वियसली नॉट गोइंग टू वर्क ईदर. So we are just going to go with B option over here. This makes sense. Let's just move on to the next question. Then I'm going to take a break. The break is going to mean a jump cut. A student determines the density rho of steel by taking measurements from a steel wire. Okay. We are supposed to find the density of steel by taking measurements from a steel wire. The mass is given to us in grams, and the length is given with the absolute uncertainty. All these are absolute uncertainties because these are not the percentages. He uses whatever equation that we have. We are supposed to find the percentage uncertainty in his calculate value of density. Well, the fastest way to solve this is to first find the percentage uncertainty in each of these quantities over here. So I'm just going to find the percentage uncertainty over here. This is going to be 0.1 divided by 6.2. I'm not going to worry about the units. This is going to give me 1.6%. I'm not even concerned about the significant figures over here. So this is going to be 0.1 divided by 25 multiplied by 100, and that gives me 0.4%. And the last but not the least, 0.01 divided by 2 multiplied by 100, and that gives me 0.5%. The rule says that if the quantities, if the physical quantities that we are measuring, if they are being multiplied or being divided, we will always add the percentage uncertainties or the fractional uncertainties. But I'm a fan of percentage uncertainties, and this question is also about the percentage uncertainty. So that means it's already solved. So let's see. Percentage uncertainty in rho should be equal to, we are going to ignore the constants over here which does not have any units, so 4 gaya. So this should be m में हमारे पास कितनी है percentage. We happen to have mass, and the mass has a percentage uncertainty of 1.6%. Add to it, we happen to have the diameter square. So be careful. Square operation means that we need to double the uncertainty, percentage uncertainty. We have to double the percentage uncertainty. So that means if we were getting d raised to power 3, that would mean we would have to multiply it by 3. But nevertheless, this is only a square, so we're just going to multiply it by 2 over here. And the percentage in the diameter is 0.5. So this is going to be added to the length, and we happen to have, there is no power to the length L. There is only one power, and that is 1 over there. And so we just have to add the percentage uncertainty in length, and that is going to be 0.4%. And let's just see, 1.6 plus 2 into 0.5 plus 0.4, and that gives me 3%. That gives me 3%. So that should be the answer. Let's just move on to the next question, and let's just see. Sorry. I think I coughed, but the AI is working, and I'm sure the cough was not recorded. So let's just see. The AI is not working over here and moving this pen up and down. Basically, I'm using a lot of devices here. I'm using a display panel with the pen support to work on this thing. And this is my laptop, and laptop also has a touchscreen, but I'm not using that. So let's just take a break. The break is gone. Just took a break, and now we'll not have any jump cuts. The acceleration of free fall on the moon is 1.6 meter per second squared. The moon has no atmosphere. That is okay. So there is no air resistance then. An astronaut standing on the surface of the moon drops a feather. Well, the astronaut was having a blast over there, I guess. He was getting bored, maybe, so he happened to have a feather, and he dropped it just for fun. Which graph shows the variation with time of the speed of the feather during the first second of its fall? Okay, so we have no atmosphere. That means there is no air resistance. So it means that the acceleration should be pretty much constant. So let's just see. If and we happen to have the speed time graph in all the options over here, and the speed time graph would have a constant gradient, because if the acceleration is constant, that means the gradient of the speed time graph should be a constant. And the best option is obviously a, for the simple piece of cake question. Let's just move on to the next question. This looks interesting. Tennis ball is released from rest at the top of the tall building. Okay. Which graph best represents the variation with time t of the acceleration a of the ball as it falls, assuming that the effect of air resistance is not negligible? That is important. अब सबसे पहली चीज है, there is always a chance involved. If we happen to have air resistance, during its fall it might hit terminal velocity before crashing to the floor, right? तो इसका मतलब है कि if it is trying to hit terminal velocity, the acceleration is just going to be decreasing. तो हमारे पास डिक्रीज तो होगा, एक्सेलरेशन तो हमारे पास पहले पड़ी हुई वैल्यू होगी. That means during the start of the fall, the acceleration would have a value of almost 9.81 meter per second squared. So that means it cannot start from zero. So this option is already gone. Acceleration is definitely not constant because of the air resistance, because there is an imbalance of forces, and eventually it will hit terminal velocity when the reverse forces, the air resistance forces, are going to become equal to the weight. So that means eventually it is going to hit, the acceleration is going to become zero when the resultant forces acting on that tennis ball become zero. B cannot be correct because obviously it suggests that acceleration becomes constant after a certain time, which is not true. Acceleration should become zero after some time. If it does not hit the floor very early, so it is definitely going to hit zero. So the A is the best option over here. This was very simple. Not actually simple, but it required some knowledge, some power, and whatever. Anyways, let's just look at this question. Let me zoom out a little bit. ये कह रहा है, the graph shows how the velocity of an object moving in a straight line varies with time t is equal to 0 to time t is equal to t. Okay, so we have a velocity time graph. And which graph represents the displacement s of the object? Okay, we are supposed to be working with the displacement s of the object in time t is equal to 0 to t is equal to t. Let's just look at this question now. This seems to be a question that we need to work it out. Okay. We know this fact that the gradient of the displacement time graph, these are the displacement time graph. Gradient of these displacement time graph gives us the velocity, right? So what we can do is that we can work out each of these situations and see if we are getting something like this. Let's just look at option A over here. Option A का जो initial gradient है, listen, you need to understand that the tangent, we will be drawing some tangents over here and looking at the gradients. Let's see. Initially, सबसे पहले, let's just look at this part. शुरू में, if we look at the start, we are getting a gradient of 0 over here. If the gradient is 0, that means the velocity is definitely 0 over here. So this matches. इसमें match नहीं हो रहा. B cannot be the right answer. In fact, C cannot be the right answer as well, because इधर शुरू में हमारे पास we happen to have a gradient, so that means we happen to have a velocity. इधर भी हमारे पास velocity होगी because we happen to have a gradient over here. Slope है. इधर हमारे पास initially slope नहीं है. So we are only going to be concerned with option A and option D. Let's just look at the rest of the part of this part A over here. फिर हमारे पास जो है, let's just focus over here. यहाँ पे हमारे पास gradient 0 है, and eventually the gradient increases to a maximum value. That means the velocity increases to a maximum value. You can clearly see that यहाँ से gradient बढ़ रहा है, इधर से भी हमारे पास gradient बढ़ा, and then this gradient is actually decreasing, and then it becomes 0 again. So it makes sense. Gradient increasing to a maximum value. We are over here. This represents this. Oh, sorry. This makes sense. That we are over here, and then the gradient becomes 0. So this is actually this position over here. So yeah. So it matches. So far, so good. Let's just look at the rest of the part. And then again, the gradient starts increasing. नेगेटिव ग्रेडियंट है, पहले हमारे पास ग्रेडियंट ये था, 0 था, फिर उसके बाद ये ग्रेडियंट हमारे पास थोड़ा सा इंक्रीज हुआ, फिर और ज्यादा इंक्रीज हुआ, फिर ये कम होना स्टार्ट हुआ, इट स्टार्ट्स डिक्रीजिंग एंड इवेंचुअली इट बिकम्स 0 अगेन. सो लेट्स जस्ट लुक एट दिस थिंग. हमारे पास जो है इधर भी हमारे पास इसी तरीके से हो रहा है. The gradient starts increasing, that means the velocity is actually increasing in the negative direction, it becomes a maximum. तो ये हमारे पास यहां पर कहीं पे आ जाएगा, and then eventually it becomes 0. So obviously A is the right option. Oh my God, this was actually quite, a brain teaser type of question. D cannot be the right answer because D is just wrong. Anyways, let's just move on to the next question. Oh my God, question number 9. A ball falls vertically onto a horizontal ground and rebounds as shown. We can clearly see that the ball has momentum P1 downwards just before hitting the ground. After rebounding, the ball leaves the ground with momentum P2 upward. The ball is in contact with the ground for 0.020 seconds. During this time, an average resultant force of 25x on the ball. What is the possible combination values for P1 and P2? Okay. So, okay. First of all, we need to realize is that the momentum is definitely a vector quantity, so the directions matter a lot. And the force itself is the change in momentum over change in time. So that means P2 minus P1 divided by delta t, but then we have to be very careful with the signs. अभी मैंने साइन को कंसिडर नहीं किया, just working it out, just drafting it out. Let's see, what is the combination values for P1 and P2? But we can easily find this. We can find the change in momentum directly. The change in momentum itself is equal to force multiplied by delta t, which we have already, 25 multiplied by 0.02. So let's just look at this thing. So 25 multiplied by 0.02 gives me 0.5. So change in momentum is 0.5 kilogram meter ms minus 1. ये तो हमारे पास change आ रहा है. So that is a very simple question. The simple question is that we have to match the change over here. Let's just see. First things first. The ball is just before hitting the after rebounding, the ball leaves the ground with the momentum B. The ball is in contact with the ground for this during this, what is a possible combination of values of P1 and P2? Let's just see. हमारे पास जो momentum है, the first thing first is to realize is that the magnitude of the momentum of this should be higher than this. ऐसा ही होना चाहिए. तो P2 का जो momentum की value higher है इधर, this cannot be correct, so this has to be wrong. Similarly, this one is also wrong. But let's just look at this option. 0.30 minus 0.2 gives me 0.10. And if we subtract the two values over here, this does not give me 0.5, so this is wrong. And let's just look at the D option. 0.65 minus 0.15. 0.65 minus 0.15 definitely gives me a value of 0.5. So that makes it very simple. So that means this matches. D is the correct answer. Wait a minute. The pitfall. Let's just go back and redo. पहले दो तो सही है. पहले दो तो cancel है because obviously बात है. The momentum of P2 cannot be larger than P1, but then again the signs are very important. If this is, let's just say downward is negative. इस पे हम लोग नेगेटिव लगा लेते हैं, and then P2 is positive, negative, positive, right? And let's just see if it matches that idea. अगर मेरे पास है hit किया तो 0.20 minus brackets minus, let's just work this C option again. 0.20 minus brackets minus 0.30. That gives me 0.5. Oh my God. That means C is the correct answer. But what about this D option? See, this is what I was talking about. You happen to forget every time. If I can forget, then obviously you guys can also forget that way. You subconsciously just don't think about it that much, that momentum is a vector quantity, and these kinds of mistakes can happen in the examination. Let's just work this D option out as well. So 0.15 minus brackets minus 0.65. So this is going to be 0.15 plus 0.65, and that gives me 0.8. So obviously D is not going to be the right answer. C is the right answer. My God. You have to be very careful with respect to the directions. Let's just move on to the next part. 10. A sphere falls from rest through the air. We have feathers falling, we have tennis balls falling, and now we happen to have a sphere. Falls from rest through air. The graph shows the variation with time of the sphere's velocity. Okay. Which diagram shows the forces acting on the sphere when it is at the velocity corresponding to point P on the graph? Okay. Which diagram shows the forces acting on the sphere when, अच्छा इसका मतलब है कि हमारे पास जो है, first of all, let's just clarify one thing. शुरू में अगर रेस्ट से स्टार्ट हुआ तो हमारे पास maximum acceleration होगी because the gradient is going to be a maximum over here, and the gradient has actually decreased over here, but the gradient becomes completely flat over here. Zero acceleration, so we have less acceleration over here. If less acceleration है तो इसका मतलब है कि हमारे पास weight is supposed to be bigger, but the air resistance is also quite significant. Initially, the air resistance doesn't exist because the ball is not moving. But after that, the ball is moving and the air resistance definitely becomes significant to have certain impact, but still the velocity is positive. The acceleration is still positive. That means downwards. So let's just look at this thing. C or D? A cannot be the right answer because at P, we have not hit terminal velocity, so this cannot be true. B is the start, so this cannot be true. C could be the right answer. What about D? D के अंदर तो हमारे पास जो है air resistance has actually become greater than the weight. That means we would be facing deceleration. The velocity time graph is going to go down. So this cannot be true. So C is the right answer. I hope this is clear. Let's just move on to the next part. 11th question. We are going to be doing it. I'm just taking a small little break. Okay, guys, I'm back. Took a rather long break, but we are going to be doing some questions. The ball of mass M traveling at a velocity u collides with a stationary ball of mass n. Okay, so this is stationary. It has no velocity, so therefore it has no momentum. After collision, the two balls travel at velocities v and v respectively in the direction shown. You can clearly see the directions over here, and they are at certain angles, so obviously they are not in a straight line. Let's see, a student writes 3 equations relating to the collision. Which row in the table indicates the correct and the incorrect equations? Let's see, the first equation is this. This equation is wrong. The reason is very simple because हमारे पास जो है, this is not in a straight line. अगर ये वाला, if this mass was supposed to collide with this mass and this mass also tends to move in this direction and this mass also moves in the opposite direction or maybe in the same direction or maybe in the same line over here, which is the horizontal line over here with respect to this diagram, so here that would have been correct, but obviously this is wrong. The reason is that both the masses are moving at certain angles. You can see that over here after collision, right? So that means we have to ignore these. The first one should be incorrect. This is wrong. Oh my God. We have to select the incorrect ones. These are incorrect. So ye and ye. This cannot be true. This cannot be true. Anyways, let's just move on to the second and let's see. MV sine 30 and MV sine 30. Where, as I discussed in my physical classes, I told you guys the momentum should be conserved in all directions. So that means the momentum of this ball must be equal to the momentum of this ball in the, let's say, this is the vertical direction or maybe the y-axis. ये वाला जो momentum होगा वो इसका हो जाएगा and that should be equal to the momentum of this. So if we are going to resolve this in the y-axis, so that means V mv sine 30 should be equal to mv capital sine 40. So that means this one is correct. So this can be correct. Okay. This can be correct. Oh my God. The first one was already, I marked it incorrect. So that obviously this is correct. That is correct. And last but not the least, this option, let's just look at this option. What about that we resolve this in the x-axis? If you're going to be resolving it in this direction, then the momentum should be this momentum. That means mu plus mv, but mv is 0, so we're just going to ignore that, should be equal to the total momentum, the components of the momentum in the horizontal axis, which is represented by green over here. So that means mv cosine 30 degrees plus capital M capital V cosine 40. So that means this one is also correct. So this is the correct option. So this is wrong. This is not incorrect. So this is the correct option. D is the correct answer. That was easy. Let's move on to the question number 12. And let's just look at this question. Let me zoom in a little bit. A rigid rod XY as an object of weight W. As an object of weight W at one end. We can see that. The rod is in equilibrium, resting on a roller at Z. This is the roller at Z. And a vertical wall at X. This is a vertical wall. This is preventing it from actually turning, rotating. The diagram shows the direction, but not the magnitude of the forces RW. What is the direction of the force at X? Well, since this is an equilibrium, if this is an equilibrium, then there is a way. The fastest way is to just, extend the line of action of all the forces and see where they intersect. If we extend this line, and then we know this is an equilibrium, so they are going to meet at a certain point. So we are just going to extend this line. We can see they are intersecting at this position. So the unknown is the x. From here, another line is going to be coming out. That should also be in this direction. So it means D should be the right answer. Fastest way to do it, fastest way. Let's just move on to the next question. In a large container in an oil refinery, 3 oils of different densities are mixed. No chemical activity occurs. Okay. The mixture consists of the mass of oil, the mass of oil, the mass of oil, and the densities of all the oils that we have available. What is the density of the mixture? So combined density should be equal to total mass per total volume. Okay, that means it's a very simple question. We are just going to move it over here so that I have more space to work with. So let's say, suppose mass to हमारे पास है सारे के सारे, we just have to add the masses together. So that means the total mass, let's just write it down, density, total mass is actually 1,200 plus 1,500 plus 4,000 and divided by the volume. So let's just see, we will have to find the individual volumes over here. So density is equal to mass per unit volume. So volume is equal to mass per unit density. So we are going to find the individual volume. So that means 1,200 divided by 1,100. Volume is equal to mass per unit density. So that makes sense. And this gives me 1.09 plus we have 1500 divided by 860. And that gives me 1.74. Not concerned about the significant figures. We'll obviously round it off at the end. It's 4000 divided by 910. And that gives me 4.4. And finally, 1200 plus 1500 plus 4000 divided by bracket closed 1.09 plus 1.74 plus 4.4 bracket closed. And that gives me 926. So 926.7 kilogram per meter cube. So that means the closest value, rounding it off, the three significant figure is actually A. So A should be the right answer. Let's move on to the next part. Two coplanar forces act on the rim of a wheel. Okay. The forces are equal in magnitude. Which arrangement of forces provides only a couple? Well, a couple is a kind of a moment in which the two forces must be completely parallel and must be exactly opposite, and there must be a perpendicular distance between the two forces. These are parallel, but the problem is that they are not opposite to each other. So this cannot be a couple, this cannot be a couple, this cannot be a couple. But look at this thing. We happen to have a force over here, we happen to have a force over here. Both the magnitudes are equal, and then there is also a perpendicular distance between the two forces. So this is going to be a couple. That was ridiculously easy. The density of air on the earth decreases. Oh my God. The density of air, oh my God. The density of air on the earth decreases almost linearly with height from this at sea level to this, so almost linearly. So that means we are just going to assume that that is actually linear change at an altitude of 5000 meters. That means I need to draw a diagram first. Let's just look at this thing. So first of all, let me just draw a scene over here. And this is the land over here. So this is my sea level. And sea level ke baad we happen to, let's just draw something over here. Let's just suppose there is a mountain over here. So yeah. And the idea is that we are at sea level. The density of the air on the earth decreases from a height of at sea level. So density is actually, this value is, the density is actually 1.22 kilogram m minus 3. This is the density over here. And then we travel an altitude. That altitude is represented by this height over here. So I'm just going to make this. This is 5000 meters. And the density here is actually less. And that density is actually 0.74 into, sorry, 0.74 kilogram per meter. So, okay, that does it. Atmospheric pressure at the Earth's surface on the particular day is 1000 pascals. Oh, sorry, 1 into 10 to the power 5 pascals. Okay. So that means the pressure, the total pressure, that means the total pressure that is exerted on the surface of the Earth is this. The value of G between the Earth's surface and the altitude of 500 can be considered to have a constant value. That means we are not going to be changing this value, which is the acceleration due to gravity, and that makes it constant. What will be the atmospheric pressure at an altitude of 5000 meters? Okay, so this is something we need to do. Now, this is a difficult question, definitely. Okay, so we have let's suppose the atmosphere is still this point. So yeah, हमारे पास इस पोजीशन से लेकर इस पोजीशन तक जो हमारे पास प्रेशर आ रहा है, that is actually 100,000 pascals. And what I need to do is to find the pressure over here and then subtract the two pressure to find the pressure at this point. My target is to find the pressure at this position. At this position, I want to find the target pressure. That means the remaining pressure over here. This is what I need over here. So we're going to be doing this part. And this requires that we have this value. We already have this value. This is the total pressure. And we need to find this pressure. For this pressure, we have to make the assumption is that the density is changes linearly. So that means हमारे पास direct proportionally कम हो रही होगी. अगर ये density linearly change हो रही है, so what we can do is that we can just find the average density and then work our way out. We can use H rho G over here because we happen to have air. Air is also a fluid. So let's just use this. So pressure difference between sea level and 5,000 meters is equal to H, change in height. Change in height is 5,000 into density. The average density, I have to find it out. So 9.7 plus 0.74, 9.7 plus 0.74, and then I'm going to divide this entire value by 2. So I'm getting an average density of, oh, sorry, my mistake. That is 1.22. 1.22, this and this. My mistake. This is the acceleration, my God. 1.22 plus 0.74, and then divided by 2. So that gives me 0.98. 0.98 is the density multiplied by the acceleration due to gravity, which is this value over here, and that is going to be 9.7. Let's just find this out. 5,000 multiplied by 9.8, 0.98, sorry. 0.98 multiplied by 9.7, and that gives me a pressure of 47530 pascals. Okay, so that means we have this pressure, and all we need to do is that we subtract this pressure from this value. So pressure at 5,000 meter should be equal to 100,000 Pascal minus 47530. So minus 1, 2, 3, and that gives me 52470 pascals. We need to just locate the value which is the closest, and rounding it off to 2 significant figures. So C is going to be the right answer. This was a difficult question. You need to work this question out yourself. I would recommend that you pause this question right now and work this out yourself. Use this logic, or you should be able to arrive at your answer. Okay, so that does it. Let's just move on to the next part. A parachutist is at a constant terminal velocity. Okay, this statement is not correct. Terminal velocity per head, that means the velocity is definitely not increasing. So that means there won't be any gain in kinetic energy anymore. So gravitational potential is falling. If it is falling, the gravitational potential energy must be decreasing. But there won't be any increase in kinetic energy because we are at constant speed. So gravitational potential, this statement is not correct. That means we need to find the statement which is not correct. Gravitational potential energy is converted into kinetic energy of the air. This is absolutely not correct because this is the right answer actually. The gravitational potential energy is converted into kinetic energy of the parachute is definitely sorry. My God. No. This statement is not correct. I misread it. The parachutist is falling at constant velocity. That means is converted into kinetic energy of the air. Definitely, yes, that would be converted. Air ki kinetic energy mein to fark aayega. So we need to be careful with the impulse. So we should not be impulsive. So this cannot be the right answer, because we have to talk about the parachutist. The gravitational potential energy is converted into kinetic energy of the parachutist. No, that is absolutely wrong. No, that is absolutely correct. In fact, because no. The gravitation is converted into kinetic energy of the parachute. That is absolutely wrong. So एक minute यार, I just need to work this question out again. Just give me a minute. Once again, I need to be more clear in my explanation. The parachutist is falling at constant velocity. Okay, that means the velocity is constant. That means no conversion to kinetic energy is ever happening. Which statement is not correct? Let's see. First of all, let's find the statements that are correct. Gravitational potential energy is converted into kinetic energy of the air. That is correct, because upon hitting, that would happen. The air molecules are going to move faster. Uh, uh, Upon hitting the parachutist. Gravitational potential energy is converted into kinetic energy of the parachutist. No, that is not correct. So we are just going to leave this and we are going to move on to the correct options. Gravitational potential energy is converted into thermal energy of the air. That is also true. Gravitational potential energy is converted into thermal energy of the parachutist. That is also correct. So this is the option that is incorrect and we need to find the incorrect answer. My God. Question number 17. Okay. A boy on a bicycle starts from rest and rolls down a hill inclined at 30 degrees to the horizontal. So we happen to have a situation where we have, let me just zoom in a little bit. We need to be working this question out. So we have a hill that is inclined at a certain angle. Let me just incline this. Let's just see. Okay. And this angle is at 30 degrees. Okay. The boy and the bicycle have a combined mass of 25 kg. Okay. So we happen to have a bicycle. And let's just draw a bicycle, and this is the boy. And this boy is actually riding this bicycle. Okay, so we have this idea. Have a combined mass of 25 kg. That means its weight is going to be acting exactly downward. And that is going to be 25 into 9.81. So that should be in newtons. Well, nevertheless, there is a frictional force of 30 Newton, which is independent of the velocity of the bicycle. Okay, so we happen to have a frictional force that is acting in the opposite direction, and that is 30 Newton. What is the kinetic energy of the boy and the bicycle after rolling down 20 meters down the slope? Okay, so let's suppose we have already traveled 20 meters. Let's just mark this over here. From here to here, let's just suppose this is actually 20 meters. If this is 20 meters, and we need to work this out, what happens, what would be the, what is the kinetic energy of the boy and the bicycle after rolling down 20 meters down the slope? So that means what we have to do is that we need to understand this thing. We definitely have a height decrease from this point to this point, right? That means this is the height decrease. So this would be GPE. The gravitational potential energy actually decreases, and it must have gone into the kinetic energy of this bicycle. Additionally, it is simply rolling down the hill, so no effort is being done by the bicyclist. So that means the GP is actually converting into kinetic energy as well as the work done against friction. So we can write this down. So GPE, the gravitational potential energy, is actually converting to kinetic energy plus the work done against the frictional forces. So that means we can work this out. Let's see, what is the kinetic energy of the boy? So that means GPE should be, we need to find this height. And this height is important because we need this value of this height. And we can use simple trigonometry to find this height. And that should be 20 sine 30. Because if this is 30 degrees, so this is also going to be 30 degrees. And that should be 20 sine 30. I'm just going to write this down. 20 sine 30 multiplied by multiplied by the mass. Mass is actually 25. So 25 multiplied by mgh, that is the gravity 9.81. And kinetic energy is Ke plus the work done against the frictional force. And that force is 30 multiplied by the distance traveled is 20. So that is the work done against the frictional force. And we can easily find Ke. Let's just work this out. So 25 multiplied by 20 sine 30 multiplied by 9.81. We are going to subtract this 30 into 20. That gives me a value of 1853. So 1853, the closest value is actually this one. So this is going to be A, and that does it. That was easy. Let's just move on to the next question. 18. An escalator is in an underground station, has 250 people standing on it, and is moving with a velocity of 4.3 meter per second. Okay. The average mass of a person is 78 kg. So we will be needing to multiply these two values to get the total mass. And the angle of the escalator to the horizontal is again 40 degrees. What is the minimum power required to lift these people? Okay. The minimum power. We'll have to draw another diagram like this. And let's say this is the horizontal, and the angle is 40 degrees. And we have 250 people. So we have 250 people. I'm just going to represent it by a solid sphere, which represents the 250 people. And that is going to be the total mass downward is actually, the total weight downward is actually 250 multiplied by 78 multiplied by 9.81. That is the weight downward. And the angle of the escalator, this what is the, okay, and is moving with the velocity of this. We have the velocity. We have the velocity, which is, I'm just going to mark this velocity with a different color. So this is the velocity, and that is 4.3 meter per second. Okay. So, okay. Next step, what is the minimum power required? So minimum power would mean that there is no frictional force. Let's assume that the minimum power would ignore the frictional force. So let's just work this out. And the power, there is a shortcut formula. Power is equal to force into velocity. So if it is rolling down, we can find the force that is carrying it downward, since there is no reverse force. So the force that is carrying down is the component of the weight down the slope, and that is always mg sine theta multiplied by v. You need to refer to some of my other videos to actually understand this idea, why this is the component, but just memorize it for now. The component down the slope, that means if there is, the idea is that if we happen to have a weight over here, there is always a component down the slope that will carry it downwards. सीधी सी बात है. So the mass, total mass is actually 250 into 78 multiplied by the gravity 9.81, and this is going to be sine 40, and we are going to multiply it by the velocity. Velocity is actually 4.3 meter per second, and so the power should be, and we need it in kilowatts. So first of all, we're going to find it in watts, and then we are going to convert this. So 250 multiplied by 78 multiplied by 9.81 multiplied by sine 40, bracket closed, and we also multiply it by 4.3, and that gives me a huge value, which is somewhere, I'm just going to round it off to three significant figures. So give or take 5.4 into 10 raised to power 6 watts. Okay. So we need to convert this into kilowatts because all the answers are in kilowatts. So let's just see. That would be simple. Oh my God. So we just need to change this into 10 raised to power 3. So we're just going to multiply it. So that is going to be 10 raised to power 3 now. I don't know. मेरे से कोई, I think I made a mistake. So if I just go in, let me just do it again one more time. I just want to calculate this thing. 250 multiplied by 78. Just making sure that everything is in line. Multiplied by 9.81. Multiplied by sine 40. And we also multiply it by 4.3. Now I'm getting the right answer. Actually, I made a mistake. मैंने इसको 43 ले लिया था. So I just took it 43. So I had a problem with the factor over here. So this is actually 4.3. So that means this is going to be, let me just do it one more time just to be sure, because I'm getting the values, the magnitudes are different. So let's just do it. If you're not sure, just do it again. The working seems to be correct. Sine 40 bracket closed multiplied by 4.3. Now I've been very careful. So yeah, we have 1, 2, 3, 4. So 1, 2, 3. So kilowatts mein karna hai. So this is going to be 528 kilowatts. I'm getting this answer. So the closest answer is actually C. So yeah, that does it. Oh my God. I'm going to zoom out a bit. An electric motor operating a lift has an output power of 20 kilowatts. Okay, this is the output power. The lift and the passengers have a combined mass of 1500 kg. Okay. The motor raises the lift through a distance of 20 meters. How long does it take? Okay. So, how long does it take? Oh my God. So the output power is this. Power is actually work done per unit time. So we can easily do it. We can find the work done. So that is easy. That is simple. So 20,000 watts uh, is equal to work done over time. And work done is actually mgh, because we are apparently just gaining potential energy. So you there got 20,000 is equal to work done mgh. So 1500 multiplied by 20 multiplied by 9.81, and we just need the time. So this is, let's do it. 1500 multiplied by 20 multiplied by 9.81, and we are just going to divide it by 20,000. And this gives me a time of almost 14.7 seconds, which is rounded off to two significant figure B. That does it. I'm taking a small break again. So this is it. You won't be getting a break. You are going to be doing all these questions. Well, I'm just taking a small break. A small break means it's just going to be a simple jump cut. Okay, guys, I'm back. I've just switched this position a little bit because I felt that my display was actually obstructing the view, because I'm not getting a live view over here, so I have no idea that it was actually blocking some of the working over here. Nevertheless, I hope so it did not hinder some of my work. So let's just move on to the next question. The spring balance consists of a spring of length 20 centimeter, okay, with a hook attached. When a fish of mass 3 kg is suspended from the hook, the new length of the spring is 27. Okay, so we have the original length and we have the total length. So we can find the extension. Extension E, actually, extension E is, oh my God, E is actually 27 minus 20, which is equal to 7 centimeter. Be careful, this is in centimeters, and we need to find the spring constant of the spring. So let's see. So load is equal to K times extension, and the load is actually in newtons, so 3 into 9.81. And that means K multiplied by the extension, so 7 divided by 100, because we need to convert the centimeters into meters. So that would be it. Is this really, this question could be that simple? We'll check it out. Multiply by 100 divided by 7. So I'm getting a value of 420 Newton per meter. So that does it. I don't think there is anything hidden or something scary about this question. So let's just move on to the next question. Okay, let's just look at this question. A metal wire is attached at one end to a fixed point. Okay. And load is hung from the other end so that the wire hangs vertically. Okay. The load is increased from 0 to 20 Newton. We can see that 0 to 20 Newton, there is an increase in load over here. So load increases. Just going to write this down. This causes the wire to extend elastically by, okay, elastically. That means there is, all the energy can be retrieved by 5 millimeters. We can see that the extension is 5 millimeters. This causes the wire, the load is then reduced to 12. Okay. So we went back to this. And the extension decreases to 3 millimeters. We can see that. We can clearly see that. How much strain energy is released during the unloading process? So we just need to find this area under the graph. This area under the graph will represent this. That is very simple. So area under the graph, we are just going to go with what do you say that area under the graph, the area of the trapezium. So area of trapezium should be equal to half into height of this trapezium, which is this. So that is going to be, let me just look at this thing, because obviously we have to take the average value of this load and then we multiply it by this. So no. Oh, it is correct. So let's find it out. Because there is no difference between the two areas. So this means it is correct. Half into height. So height is going to be 5 minus 3 into 10 raised to power minus 3 and multiplied by the sum of the parallel sides. So sum of the parallel sides is actually, though that makes sense. So this is going to be 12 plus 20. That makes sense. Okay, my God. I think I've hit saturation. 1.2 into 5 minus 3. Oh my God, 1.2. 1.2, 1 divided by 2 multiplied by, oh my God, 0.5 multiplied by brackets 5 minus 3, bracket close, into 10 raised to power minus 3. And we're just going to multiply it by brackets 12 plus 20. That does it. And that should be 0.032. 0.032. Or we can move this 1, 2. So this is going to be 3.2 into 10 raised to power minus 2 joules. So D is the right answer. D is the right answer. Let's move on to the next question. Okay. So finally, we are in the territory of my waves. Waves are fun things to do with. The time-based setting is this. Okay, so we happen to have another time-based question. And the wire plate sensitivity is 0.2 millivolt per centimeters. That means the vertical axis, one of the boxes in the vertical direction is actually equal to 0.2 millivolts. So if we have two boxes, so that means 2 centimeters would be actually 0.4 millivolts and so on. What is the frequency of the sound from the loudspeaker and what is the amplitude of the trace of on the CROs? First of all, we need to find the center line. The center line is actually 1, 2, 3, 1, 2, 3. So this is the center line. This is the mean position, the mean line. Let's just count this 1, 2, 3, 1, 2, 3. Yeah, that is correct. This is the main position. And let's just find the frequency first. So the time period must be, oh my God. The time period is actually, we can just go for the troughs over here. So 1 box, 2 box, 3 box, 4 box, 5 box, and 6 box. Get me a glass of water. Pani ka pin, okay? Sure. So 1, 2, 3, 4, 5, 6. So we have 6 boxes. So that means the time period is actually 6 multiplied by the time base, which is 0.5 milliseconds. 6 multiplied by 0.5 should give me 3 milliseconds. If the time period, so frequency is actually 1 over 3 into 10 raised to power minus 3 milliseconds. So that means 1 divided by brackets 3 into 10 raised to power minus 3. And I'm just going to close this bracket, and that means I'm getting a value of 33333. So F is equal to 333 hertz. So which is equal to frequency should be actually 330 hertz. So that means these two. And let's look at the magnitude of the amplitude. So 1, 2, and 3 boxes. So 3 boxes would mean 0.2 multiplied by 3. And that means 3 to the 6, so 0.6. So this is the correct answer. A is the correct answer. This does it. So I'm just going to have some water. And then I'm going to follow it with green tea. This feels good. Nevertheless, now this is going to be followed by some green tea, which is very good for health. Let's move on to the next question. Oh my God, this is about the Doppler effect. Oh my God. Let's just zoom in thoda sa. And let's work this question out. A source of sound of frequency 1000 hertz moves away. Away means something is moving away from a stationary observer at the speed of this. Away ka matlab hai, that means the frequency must be decreasing. The source of sound of frequency moves away from the stationary observer at a speed of this. The speed of sound is this. What is the frequency of the sound heard by the observer? Okay, so the frequency should be less. So we're just going to use this formula. Observed frequency is actually equal to the source frequency multiplied by the velocity of air in air, divided by the speed of air. And since it is moving away, that means the frequency should be decreasing. F naught should be decreasing. Well, first of all, I'm just going to write this formula. This is the source, the speed of the source itself. So let's see. Our target is that it is moving away. If it is moving away, that means the frequency should fall. If this is supposed to decrease, that means this the denominator should increase. So that means we are going to have a plus sign over here. So F naught is equal to FSV divided by V plus Vs. And the thing is, we just want this value to be less somehow or another. We have two values, so this one or either this one. So let's just find this one. The answer. F as the frequency of the source is actually 1000 hertz. This was the original frequency if it were stationary. The speed of sound is actually 330, and plus we have 30 over here. So this is going to be 1000 multiplied by 330 divided by brackets 330 plus 30 bracket close, and that gives me a value of 916.6. So it has to be B. Chelsea. Let's move on to the next question. Oh my God, you require a table. I'm just going to use a table. So just give me a minute so that I can arrange the table over here. But that table needs to be memorized by you guys. I will not memorize that table, but you guys are supposed to memorize it. I'm just going to bring in a table. Just give me a minute. So we are back. I found it. Basically, this is the table that I said I'm going to be referring to. And we have this table. I'm sure because of video compression, this table may not be that clearly visible to you guys. But still, nevertheless, I'm going to be using this table. If you're going to WhatsApp me, I'm going to send it to you guys, or I'll just provide you the link. You can find it on the internet anywhere. It's just an EM spectrum table that needs to be memorized. And each of the principal radiation of the electromagnetic spectrum has a range of wavelengths. Which wavelength is correctly linked? The target is to find this out. Is correctly linked to the radiation. Let's see. Gamma radiation, gamma ray has a wavelength of 10 raised to power minus 9. Let's just look at gamma rays. It ranges from, for gamma, it actually ranges from 10 raised to power minus 10. Sorry, we're just going to work in the opposite direction. So this is going to be 10 raised to power minus 16 to up to 10 raised to power minus 10. So that means 10 raised to power minus 9 is bigger, is actually larger than this range. So obviously this cannot be true. Let's see about the microwave. Microwave has the range between 10 raised to power minus 1 to 10 raised to power minus 3. So that means this is less negative. So my first range here. And we happen to have a value of minus 5, which is actually way smaller. So this cannot be microwave. This cannot be microwave. But what about the UV? Ultraviolet is actually 10 raised to power minus 7 to 10 raised to power minus 8. And ultraviolet actually is 10 raised to power minus 8. So this does match, but barely. But let's see. What about this? X-rays. Let's look at X-rays. And that ranges from 10 raised to power minus 13 to 10 raised to power minus 8. So X-rays are actually smaller. The value given is actually smaller than the range of X-rays. So this could not be true. So C is the right answer. This is how you use this table. So you just need to memorize this table and that would be it. Anyways, another question. A stationary wave is set up on a stretched spring. The diagram shows the string at 2 instants of time when it has maximum displacement. Okay. The oscillation of point P on the string have an amplitude of A. Okay. What is the distance moved by P from the position shown in the diagram after half a time period of the wave? Okay. So we happen to have a stationary wave. Let's see. Let's just work between two nodes, node to node. We are just going to work between two nodes and understand this idea. If we are starting this with this idea, so let's see. We're going to divide the time period after half a time period. So let's see. After one time period, what is going to happen is that it is just going to move like this. One time period, quarter time period, half time period, 3/4 time period, and eventually one time period. So it will just come back. So our target is to find what is the distance moved by P from the position shown in the diagram after half a time period of the wave. So that means it will move till this position. This is quarter, and this is actually half. So that means the total distance moved is actually this. This is the total distance moved. So what is the distance moved by P from the position shown in the diagram after a half a time period? This is going to be 2A. That's easy. Let's just move on to the next question. Which statement is an example of the diffraction of light? Okay. The addition of the amplitude, diffraction means spreading up of the light, right? When it passes through an opening. The addition of the amplitude of two beams of light which are in phase, the change in the direction of the beam of light when passing from air, that is actually refraction. This is actually refraction, so this cannot be true. The separation of the beam of white light into a spectrum of colors using a prism, no, that is dispersion. A spreading of beam of light as it passes through a small hole, that is correct. That is the true definition of refraction. Sorry, diffraction. Let's just move on to the next question. Oh my God, I'm just going to zoom out a bit. Let's look at this question. A sound wave of wavelength lambda are emitted by loudspeakers and pass through two slits P and Q. Two sound waves from the slits meet at R. Okay, so this is the position where these sound waves travel and meet at this position. What is the condition for an intensity maximum loud sound to be detected by the microphone at R? The amplitude maximum, they must add constructively, right? So the amplitudes must add. The amplitudes of the two waves at R must be the same, not necessarily. Because of the spreading involved, the amplitude of Q would be slightly smaller. So this cannot be true. The distance PQ must be smaller than the wavelength lambda. What difference would it make? None. The two waves from the slit must have traveled the same distance to R. Not necessarily. Must have traveled the same distance. The two waves must be in phase at R. That is absolutely true. That means they must interfere constructively. If one of the wave is like this, the other wave can be like this, and yet their amplitudes are going to add up, match up. So that would make an intensity maxima. So D is going to be the right answer. Let's move on to the next question. Question number 28. Coherent light passes through the double slit, producing bright and dark fringes on a screen placed parallel to the plane of the double slit. Oh my God! In the examination, this is going to happen with everyone. Everyone is going to hit saturation at one point in time, and you are just going to be feeling, yeah, this should end now. But you won't be getting breaks, so you will be working on the edge of your seat. But let's see. The coherent light passes through the coherent means constant phase difference. Coherent light passes through the double slit, producing bright and dark fringes on a screen placed parallel to the plane of the double slit. The intensity of the light from each of the slit is initially the same. Okay. The intensity of the light passing through one of the slits in the double slit is now increased. The frequency of the light remains constant. What is the effect on the appearance of the fringes on the screen? Okay. The intensity, if the intensity is increased, that is only going to affect the brightness, but it will not affect the separation of the fringes. So no change in separations. Maximum intensity of the dark fringes would be greater. No, maximum intensity of dark fringes would be greater, definitely greater. So that means they're not going to be that dark anymore. So C is going to be the right answer. Let's just move on to the next part. This is no longer part of your syllabus. It has moved on to A2. This is also not a part of your syllabus. And once again, two parallel plates potential. No, this is also out of your syllabus. Okay, this is something that we can do. The potential difference V across a filament lamp is slowly raised from 0 to its normal operating value. Which graph represents the variation with V of the current I in the lamp? This is something we have already done in the past. In your O levels, we are very familiar with this idea that the resistance tends to increase. The resistance is going to increase when the graph starts curving towards the V side. So this is an IV graph, and you can clearly see that this graph is actually curving towards the V side. So that means the resistance is actually increasing over here. So A must be the right answer. Next step, two lamps are connected in series. One lamp is rated this and the other is rated this. Which statement most accurately describes what happens? The problem is that this is correct. Two lamps are connected in series to a 250 volts power supply. So that means one of the lamp is going to be getting 240 volts, which is correct, and that means it is going to dissipate 60 watt, and the other is going to dissipate 2.5 watt because it is getting the full voltage. Which statement most accurate? Both lamps light at less than their normal brightness. Nope. Both lamps light at their normal brightness. That is correct because they are both getting the right amount of voltage because they are in series, and apparently we have a 250 volts supply, and 240 plus 10 is actually 250. So yeah, they are going to only the 240 lamp light. No, the 10 volt lamp blows. No, bhai, this is not going to be true. Anyways, next step. Which lamp is used to define resistance? Which equation is used to define resistance? Okay. Define resistance. The definition of resistance is simply the ratio of voltage over current. So V is equal to IR. So potential difference is equal to current into resistance. So B is going to be the right answer. So this is the definition. Let's see, 35. The charge that a fully charged car 12-volt car battery can supply is 100 kilocoulombs. The starter motor of the car requires a current of 200 ampere for an average period of 2 seconds. I'm just taking a break and then I'll be back. Okay, guys. So let's just work this question out. The charge that a fully charged 12-volt battery car can supply is actually 100 kilocoulombs. Okay. The starter motor of the car requires a current of 200 ampere for an average period of 2 seconds. Okay. The battery does not recharge because of a fault. What is the maximum number of times the starter motor of the car can be used? So that means we have only 100 into 10 raised to power 3 coulombs of charge available. This is the total charge, right? So this is the total charge that is available to us. So what we need to find is the charge that is actually used to start the car. So charge needed is actually, needed is actually 200. Q is equal to IT, so multiplied by time. This is going to be 2. So 400 coulomb is the requirement. So let's just see. We have the total charge and we have this charge is needed to start the car. So let's just divide this, keeping this as the numerator and this the denominator. If we divide it, we are going to find that the number of times we can start the car. Let's just do that. So 100 into 10 raised to power 3 and divided by 400. So that gives me 250. So 250 times we can start the car. Let's just move on to the next part. Okay. A potential divider circuit is formed by connecting a battery of negligible internal resistance in series with two variable resistors as shown. Okay. We do not have any internal resistance. The variable resistors have resistances Rx and Ry. Okay. Vx is the potential difference across Rx. So this is Vx. Rx and Ry are both changed at the same time. Okay. We are making changes to this. Which combination of change must cause Vx to increase? If we want to increase Vx, we need to increase Rx because more work needs to be done in pushing the charge through this resistive element if the resistance is increased. So that would increase Vx, and we also need to decrease this Ry so that major chunk of the EMF falls over here. So Rx should be larger and Ry should be smaller. So B should be the right answer. Let's just move on to the next question. In the circuit, contact may be made at any point along the 3 ohm resistor, potentiometer. So, okay, so this is the potentiometer. That means if we are just going to connect it over here, that means we are only going to be seeing 2 ohms over here. If we are going to connect it over here, that means we are going to be seeing 2 plus 3, that means 5 ohms. Okay. But then again, we have ground over here. So let's just do this. The battery has an EMF of 9 volts and negligible internal. So what is the maximum range of the output voltage? Let's just look at this thing. So maximum range should be that we connect this over here. Maximum range. So that would give me the minimum value. So let's just start with the minimum value. So that is going to be 9 volts. Okay. So 9 multiplied by, so V across 2 ohms should be equal to 9 multiplied by the target resistance, which is 2 ohms, divided by the combination of all the resistance in series. That is going to be 2 plus 3 plus 4. And that is going to be 5 plus 4, 9. So 9 multiplied by 2 divided by 2 plus 3, 5. 5 plus 4, 9. So 9 divided, so this is going to be 2. So that means 2 volts. It should start with 2 volts. And the maximum value should be we are going to connect it over here, and we are just going to remove this. So that means 9 multiplied by V across 5 volts, 5 ohms should be 9 multiplied by, I'm using the potential divider formula, which is actually V out is equal to V in multiplied by one of the resistances. Let's suppose target resistance. I'm just going to write it down. Target R divided by total R. So you can use this formula if you ever get caught. You will not have to find the current. Otherwise, you will have to go find the current and then work this out. This is going to take ages, and it's just going to waste a lot of time. So across 5 ohm, because we are now going to be seeing 5 ohms over here. So 5 multiplied by the total resistance is again 9, 5 volts. So let's just go for this one. This is the right answer. That is it. Let's move on to the next question. Oh my God, this paper has already ended, almost ended. A gold nucleus undergoes alpha decay. What are the nucleon number and the proton number of the nucleus formed by this decay? We already know that if Au gold 185 79 emits an alpha particle, we are going to be left with another element. Let this be element X. The nucleon number is going to decrease by 4. So this is going to be 181, and the proton number is going to decrease by 2. So this is going to be 79 minus 2, and that is going to be 77. So plus alpha 42. Anyways, what is our target? The proton number is going to be 77. So 77. And the how many alpha? Okay, just one alpha. So the nucleon number is going to be 181. Nucleon number is going to be 181. Nucleon number is the sum of the protons and the neutrons. Which row gives the correct classification of protons, neutrons, and neutrinos? Protons are the hadrons. That is correct. Actually, these are the baryons, and baryons are hadrons. Electrons are the leptons. That is correct. And neutrinos are also leptons, so B is the correct answer. Last question of the day. Which equation represents beta positive decay? That means this is a positron. So in positron emission, a proton converts into a neutron, and a positron is emitted with a neutrino. So D is going to be the correct answer. So that does it. We have done all 40 questions, and I'm sure every question is correct. If you like this channel, please consider subscribing. My target, I have just begun recording, and my channel is not only going to be having videos over here about the lectures, but it is going to be something else beyond this. I'm also going to be talking about everything from politics to jo bhi samajh mein aayega, I'll do that. This is more going to be an entertainment channel than an education channel, but education is more important. So guys, please consider subscribing this channel. Thank you guys so much for watching this video. I'm going to be recording the paper 2 of this. I'm going to be doing some P1s in the initial phase, because P1s is something that is more challenging than P2. P2 is a chill scene. But I'm going to be doing this systematically, periodically, and also for A2 classes, I'm going to be doing those recordings as well. But nevertheless, please subscribe this channel. Kar lo bhai subscribe. Anyways, guys, take care. Dismissed.